Okay.
Looks like you're started. Looks like you're on it. Thank you.
Yay, I'm winning. Okay. Okay, so we are HVAC Systems. I'm Rodney Cornel. Thank you for having us and also welcoming us as a new lifetime sponsor of the Passive House Alberta chapter here. We are a company that started in BC over 22 years ago with our company president, Jivan Thacker. And we have service divisions in Alberta and BC and have been active now in Alberta for about 2 years. We'll be having 2 new people starting with us in May 2022. So please stay tuned for a new photo to be updated. We provide commercial, healthcare, industrial, institutional, multifamily, net zero and passive house solutions. We serve currently the provinces of BC and Alberta, hopefully soon Saskatchewan, and the territories of Yukon Territory and the Northwest Territories, with branch offices in interior BC, Edmonton, Alberta, and starting this week, Victoria Island, BC, with our head office located in Vancouver, BC.
Excuse me, Rodney. I'm sorry to interrupt. Could you put the presentation view on your PowerPoint?
So I am an engineering account system representative with HVAC Systems for Alberta office for the last 6 months. We pride ourselves on providing the right product for the right application in general. My history is I graduated from University of Alberta Mechanical Engineering back in 2003, worked about 5 years in the oil field in exploratory services, then started my plumbing and HVAC career in November 2008, where I worked for the last 13 to 14 years in consulting engineering with FSC Consulting Engineers, Stantec Consulting in Edmonton, and TWS Engineering Limited in Edmonton, where I worked with FSC about 2 years, Stantec for 8 years, and about 2 years for TWS Engineering. And for the last 6 months, I've been decided to change and take on the role as inside sales and engineering account representation with HVAC Systems and Solutions, as I believe in their ultimate goal of providing unique solutions for HVAC systems needed in our industry currently. We offer about 20 to 22 products for the Alberta territory, and for British Columbia, we have over 42 product lines. As you can see here, we probably have closer to about, I would say, 42 clickable links, and that's us basically retooling our website to make it easier for you to find the products you need. Current examples of our installations for Passive House is the UBC Skeena in the Okanagan, where we have a Swegon Gold ventilation unit and Comac water heat, domestic hot water air source heat pump units. We also have the Subaru dealership, Scott Subaru in Red Deer, which was also a Passive House project, the Swegon ERVs. UBC Evolve, which is still under construction. And here's an example of the Alt Housing and Healing Center, which is also currently under construction. So we thank you for joining our presentation. And I would like to transition now into introducing Ashkan Oghabi of Swegon North America, who will introduce you to Swegon Energy Recovery Ventilators for Passive House.
Hi, good afternoon, everybody. I just wanna share my screen if I can. Do that. Let me figure it out. How can I? Okay, got it. Okay. Okay, cool. Thank you. I'm in Connecticut today, but my base home is in Toronto. I'm also a mechanical engineer. Did my bachelor and master in mechanical engineering. My master I've done in the University of Saskatchewan, and with Carrie Simonson. I don't know how guys, do you know, or ladies, do you know him or not? But he is one of the people leading in the energy recovery units that doing the research. So I'm gonna talk about what kind of the solution that Swegon can be done in the high performance building, and specifically, I know this meeting is about the passive house. And passive house is one of the leaders in the kind of getting the way or path for everybody get to the high performance building. Little about the Swegon. We are the ventilation company, so we are kind of the Swegon knows himself or itself as a company leading to provide a high performance. Okay, I think it's better now. Sharing my screen, so sorry about that. Providing the indoor air quality and comfortable environment for the people inside the buildings. And we know that we are majority of our times is even with the COVID, we noticed more than before that our time is spent indoors, and how's that kind of the 87% of our time, and indoor air quality research shows that have a great impact on our performance and our productivity. And with the thing with pandemic, what learned, or it's kind of lesson learned, that we should not overlook the ventilation and the kind of the what we need to do in inside our buildings, and be more sensitive to that. Okay, is my screen can be seen properly, Rodney? I'm not sure if.
Yeah, it's coming
Okay.
in loud and clear.
Okay, cool. We, as a kind of the ventilation in the passive house solution, we do have the dedicated outdoor air system that bring the fresh air inside the building. That the picture you're seeing, the gold air handling unit, it can be that we are talking about today. We have some VAV modulation damper specifically built for passive house, and I'm gonna talk about what's the differences in the passive house versus the regular built building, or the code building that we are referring to. Transfer grills, or the kind of the R and the terminal side, or grills and diffusers, and also we have this is the ERV for residential that you are seeing is integrated to the cabinetry for each apartment. So that's kind of the product that we have, and all of these solutions are get us to the higher performance building and the kind of the lower energy consumption. So that's kind of the goal. We want to talk about the solution that we are having to offer. Looking at the Swegon is kind of one of the leaders in the passive house education project. So it's been involved in you can see the projects all over the world, including North America and European countries. That's kind of where it's kind of maybe after our homes is the next place is offices, and the schools are the people are spending most of their time, or the workplace, and also the education places or institutional buildings. More on the kind of the projects that naming are coming up. This is all projects across the world. It's more than 100 projects being involved with the passive house, and the closest one to you guys in Edmonton is a Subaru dealership. That's kind of we have been involved in the design for that. So kind of Mike Woosley is our business development manager, and this kind of showing the Swegon kind of the timing of the year is from 1973, where there's a shortage of oil. People was lining up to getting the gas, and kind of getting to the level that where we are in the in Swegon. This is kind of the course that also getting the credit for FIAS. So if you guys are a member of FIAS and you want to use a PDH credit, that's kind of you can claim this course as a point like 0.5 credit as a kind of the one. There's a couple of organization is involved in the Passive House. One of them is Passive House Institute, which is kind of originated from Germany. And their goal is kind of being the energy efficient and comfortable and affordable at the same. That's kind of the mission they have with this standard. And FIAS is kind of having the same. FIAS is the version of the Passive House that's kind of be customized and tailored for mainly for North America due to the kind of the variety of the climate that we have. In North America, we have a wider range of the different climate compared to the European countries, and kind of the same aiming, chasing the same goal is kind of to be energy efficient and providing the comfortable and affordable house place to live in. And the building size, if you're gonna step up, there are 5 key characteristics with the Passive House. Is kind of the insulation, thermal bridging, air tightness of the building, and windows. And in kind of these 3 on the right side of the screen, it can be categorized as one that kind of can be put in one bucket, and air tightness and continuous ventilation can be put in the separate bucket. The reason is the more airtight we make the buildings, it means that we can save more energy on the cooling and heating load. And this other aspect of the solution is we need some continuous ventilation to bring the fresh air into the building and exhaust the stale air from our buildings. So that's why it's kind of the more airtight, we need the more ventilation and continuous ventilation. And it's kind of the ventilation is playing a role in achieving the high performance or Passive House building, because it's kind of this is the energy user consuming energy in the building. And the other ones is trying to minimize the loads inside the building. This is what we used to see as the air tightness. So the kind of using you are seeing most of the time in the buildings or condos or houses, the kind of wrapping the Tyvek around the building. This is not what we are talking about, air tightness. This is what is more on is a true solution. Thicker walls is truly wrapped with the vapor barriers and kind of eliminate any unwanted infiltration and exfiltration. So we don't want to whatever energy put inside the building goes out through the exfiltration, or unconditioned air comes to our building. So that's kind of why air tightness, we are saving the energy and improving the indoor air quality. But what is the solution? So if we don't have the air coming in, this is kind of what we need to do. We need the ventilation unit to control the humidity, the CO2 level. We need to kind of bring the minimum requirement to kind of make the comfortable and indoor air quality level higher for the occupants. If we are looking at the just ventilation, so we kind of our topic today is only dedicated on the ventilation. So if you have a leaky building, so it's kind of it's already, we don't need the mechanical. So we are on the opposite side of the spectrum. So we have a tight buildings, less heating and cooling load. So we want to bring down or shrink the heating and cooling loads, and kind of maintaining any loads with the ventilation. And if we need additional heating and cooling, we can kind of meet that one by adding to our ventilation units. But at the same time, we have to watch the electrical consumption of this unit, because as I mentioned, this is the main energy user in our building. So any kind of the Passive House building you are doing is kind of different from the other traditional building design. Ventilation is kind of taking care of the main heating and cooling as well. So we need a higher efficiency unit with the lower electricity consumption. What's the value of the Passive House on the equipment level. So on the equipment level, if you go to the certification, so it's kind of to have a couple of characteristics that we didn't, or it used to be overlooked in the older time. So one of the things is about the, other than the efficiency that's requires to be above the certain points, it's 75%, is looking at the electricity consumption. So fan power or specific fan power is a kind of the term, is kind of the matters for the passive house project. It means that for every CFM ventilation that we are bringing to the space, how much electricity are we using? So it's kind of coming as a watt per CFM in the IP units, or in the SI is the kind of the kilowatt hours per cubic meter. So that's kind of the another characteristic needs to be overlooked, to be noticed in the ventilation units for passive house. And the other thing is also looking at the overall cabinet leakage, because it's kind of the that ventilation unit is part of the building envelope, and you cannot have a leaky unit with the kind of the passive house project. So you want to have some unit with a good quality and the lower leakage, which is like a 3%, that's the requirement. So let's look at the kind of the component and the ERV and HRV. That's kind of the term. So we are using the ventilation unit with the energy recovery device. If we are kind of using the PHR, like a certified unit for passive house versus the AHRI unit. So if we go with the lowest cost versus the certified or high performance unit, what's the differences? So as an example, for the Swegon, it's kind of we need the larger cabinet. So we need a larger cabinet to kind of meet the criteria that we described earlier. So we need to able to meet that electricity consumption target. We need a larger cabinet because we need to bring down the internal pressure drop of the unit lower. And that's kind of, you can see that in the watt per CFM or specific fan power is for the lowest cost, we are looking around 1 watt per CFM versus the high efficiency unit, we are looking around 60.62 watt per CFM. And this is kind of the more on the longer term. So it's kind of bringing down the operating costs of the mechanical equipment versus this one is kind of the lowest lowest cost or capital cost on the equipment. This is kind of the value of where the value of the certified high efficiency unit coming to the play. So we compared these two units, the lowest cost, first cost, that's always a concern for owners, for designers, kind of watching the cost of the unit, how much is this money is spending on, and what's the return of investment of that specific unit that they're designing and specifying. For this one, this is kind of, we can see where does that energy goes. So if we have the ventilation units, about the kind of the majority of the energy is getting used by fans. So higher efficiency fans is kind of the solution for the high performance unit or high efficiency unit. So ECM fans is the kind of the mandatory for these high efficiency unit. And ECM fans with a direct drive or plug wheel, that's kind of the what you need to be used in the certified unit. This is the kind of the energy consumption that you're going to use to pass the air through the energy recovery device. So this is assumed that they have the same pressure, so there's no difference. And how much is energy comparing on putting cooling and heating and moisture recovery versus. Overall, that we are seeing is 10% the set a high efficiency unit using less energy compared to the low first cost option. And 10% is not a small number, it's a huge number that can be achieved with the kind of using the higher efficiency. This is the kind of the example like for Boston. So looking at the 3 degree Fahrenheit, this is the ERV with the electricity consumption of the 0.6 watt per CFM. This is kind of the where goes to the FIAS energy modeler software, WUFI. WUFI, and it's kind of the 3 degree Fahrenheit outside there, 70 degree on the return air. You're gonna get that with the high efficiency unit, you get a 60 degree Fahrenheit supply temperature. So which is majority of the kind of the time of the year, maybe it's enough to meet the loads inside the building without any additional cooling and heating. So that's why it's kind of the having this. So whatever energy we are putting inside the building, we can, with the high efficiency, we can keep that energy inside the building and kind of be a high performance solution for this passive house buildings. And this kind of the showing the internal, if you open the ERV or HRV units, so kind of the seeing the base component of the unit, there's some filtration in the return. You have a 2 air stream, one in the outside air coming, bottom part, and this one, and return is going on the top part and exhaust. So this is a rotary type ERV. That's kind of the recovering the energy that we exhausting from the building, putting back to the supplies. And having the certified unit is kind of the helping us to kind of the achieve what we have designed. So this is kind of showing the sample projects that Swegon has installed, and you can see the specific fan power for the real projects and that the unit is operating, and it's kind of it's hitting the numbers that it's designed for. So designing one thing, but commissioning and getting the result of that equipment is another thing. That's kind of what they're, when the building is going through the certification or commissioning, we need to make sure that whatever is designed for is aligned with the project scope. And this is kind of for a project with the RX14 with 2000 CFM. Yeah. So, and these are the kind of the more projects that kind of being in the offices and high schools that this is in the Brooklyn. That's kind of the 100 Flatbush primary and high school. That's kind of going through the passive house. It's under construction with the Swegon unit. This is a pre-K 12 pre-K schools that kind of Swegon has been involved in New York City. So that's kind of a completed version of the building. And this kind of another one in Queens in New York. So when it's kind of the passive house, other than the kind of the building envelope side, there are some criteria on the heating load, cooling load. So we are limited on there are some certain areas that needs the building's design needs to hit. So we cannot pass a certain amount of the heating that the building required in the design condition. So same one, the cooling, if there's dehumidification, and kind of the designing using the certified unit is kind of helping to getting these parameters easier to meet. So this is like the PHI, the German version of the passive house, but for the passive FIAS is a kind of the different numbers, but same kind of the concept that needs to be looked after. So this is the one that project in the school with the centralized DOAS unit that they're looking for 86% efficiency and 0.72% watt per CFM. And kind of comparing in the apartments, they use the decentralized solution versus for the common areas, they use a centralized solution. So that's kind of what they have done in the 100 Flatbush projects in New York. What we have as a kind of in our passive house lesson learned, we have kind of learned that it's kind of we have to be tough on the targets of the energy target. So that's in the design stage, that's all parties are involved. It's kind of we have to get defining the targets and pushing hard. And just having a high efficiency ventilation is not enough. You need to do more to kind of taking care of that the unit, whatever is designed with that apply. So it's kind of it needs the verbiage in the installation, duct leakage, any kind of the building envelope criteria or scope. Those are the kind of fixed steps needs to be done in the passive house. And many of the jobs that we are, especially from New York, one of the leaders in the passive houses, they learn that they can do more. They put in the sequence of operation. They more put it on the installation of duct or duct leakage. Those are kind of the helping the kind of the commissioning and passing the project or certifying the project easier for them. So it's kind of the higher kind of the what is kind of the there are some minimum requirement for each standard for the passive house, but even if we push the higher than what the minimum requirement is able to us to kind of do the saving on the other part of the project, like the higher efficiency ventilation may help us to use a small like the thinner insulation, or instead of triple pane windows you use a double pane window. So those are the kind of the consideration needs to be done at the schematic design to see where's the kind of the overall project scope lands and where is better to spend the money on. Is it better to put on the high efficiency ventilation over the 20-25 years of the building life, or is it kind of the better to put it on the air tightness or the building or windows type of thing that is being used on the project. And the other thing is about the location of the unit. So many times these units can be installed in the outdoor or indoor. So there are different parameters of the, if you are putting on the roof, that's kind of the thermal bridging of the unit installation may be challenging, or duct or insulating the ducting on the roof. That's the other specification needs to be looked after. So that's lesson learned through the passive house consultant and the projects that we have done. And in the commissioning phase is kind of the defining how to run the specifically about the ERV and HRVs. That's kind of the helping to kind of the keep the operating costs lower and the maintenance and the other stuff cost as the required level, as defining the steps for the pressure and balancer contractor, because it's lots of the times that the unit installing, they kind of not getting the enough airflow at the specific location of the building. And specifically for these projects, there are low pressure systems. So we need the kind of the component to able to work at the low pressure, like you are having the, for specifically for passive house, when you're doing the 3000 CFM unit, you have only 1.2 inches of pressure drop for your duct design. And you cannot having the high pressure drop component into the inside your HVAC system and still meeting the passive house requirement. So that's kind of the need to be taken, looked after, and be paying attention. Okay, that's what I have on the Swegon and lesson learned. Back to you. Who's the host? Rodney. I'm not sure. I joined late, so.
Is Rodney, do you have any more? Is that the end of the presentation? Oh, Rodney seems to have disappeared.
No, I'm still here.
Oh, there, okay.
Sorry, I just had to read something there. That's pretty much what we had planned for that portion. Ashkan, do you still have time to provide a quick overview of, in addition to the Swegon Gold unit, do you have anything we can present to them on the new Swegon Casa ventilation units for residential?
Yes, yeah, I can do that. Let me stop sharing, and then we can wait for the questions. People have any question, and then while I'm waiting, opening up there.
Does anyone have any questions about the commercial multifamily units while we're waiting for the other presentation? You can stick your hand up if you like, or write in the chat box.
So one of the things about the, maybe I take it over from here. So we talked about the ventilation units. So it's kind of the efficiency, cross-contamination of the or exhaust air transfer ratio, casing leakage, and also the electricity consumption are the kind of the parameters we need to kind of pay attention in the choosing the ventilation. Is specifically for Alberta, where is the kind of the cold climate, and is some areas getting -40, -30. It's kind of the designing the heating component. If you're adding the preheater, we need to kind of look at how you're sizing your component, because oversizing your component in the ventilation unit causes to not easily meet the targets in the passive house. So the more kind of trying to be more on the conservative side, like the oversize and everything, is kind of the pushing to you to getting the more expensive solution for passive house. And that's kind of the mindset people may have, is passive house may be an expensive solution for the buildings, which is not. It's kind of the right design that's kind of the needs to be done for the projects, and this kind of the cost is kind of comparative, is relatively equal to the regular build if it's kind of being done correctly, and over the time of the short of the time that the investment is being done on the buildings can be returned because it's being done correctly, and the kind of operating costs of those buildings are super low that can be easily meet the kind of the bring the return of investment in the reasonable time. Okay, let me.
Gee, I do have a question for you, Ashkan.
Sure.
As part of passive house projects, in addition to electric preheat and hydronic options, are we also able to provide variable refrigerant flow options as well for passive house projects?
It's not being done. The reason is if it's in those colder climates, you cannot get that enough capacity of heating from your refrigerant. So you're limited in this kind of some certain outdoor air temperature with your refrigeration cycle or the heat pump unit. So that's why you don't see those components to be as a preheat position. So common gas are getting to the stages, gas is getting out of the phase in the passive house or high efficiency building. So the only option is kind of getting the either hydronic coil with the electric boilers, or you can use the electric heater. And just as I said, it needs to be done size precisely, not to oversize your preheater. It's kind of needs to be taken out.
And for the Swegon unit, would you require preheating if your outdoor winter climate is still above -30 degrees Celsius?
If you have to do the math conversion up to -20 Fahrenheit, typically you don't need a preheater for your ventilation units. So any temperature goes below that, we recommend to just add a preheating to do the trim preheating, just to bring the outside air warm enough to eliminate that defrosting issue or frost issue on the energy cover device. Okay.
You say -20 Fahrenheit?
Yes. Yes, -20 Fahrenheit.
Thank you. That's quite low.
Yeah, it's I can go through the product itself, but I try to keep the high level. If it's needed, I can talk about a little about the technology of the product as well. It's try to kind of keep it on the not product specific, more on the solution specific on this presentation.
I think if we can see a presentation, you have a presentation about the residential product.
Yeah. Yes.
Let's go ahead with that. If sure. We have about 10 minutes, and then we can talk about more technical things if there's an appetite for that.
Okay. So one of the challenges in the passive house building or the building with the airtight envelope is kind of keeping the balanced pressure. So it means that you are kind of the only way that your air is coming from the outside or exhausting the stale air is that's through your mechanical ventilation. So any extra equipment you want to add to your apartment or to your space needs to have a proper solution to keep the pressure balanced. On the left side, you can see some pictures of having the dryer. So if you have a dryer with a direct exhaust connection, you need to have a solution to able to keep the pressure or the supply air balanced when it's that set on. Or if you have a cooker hoods, you know that there's a big discussion of should we use a recirculating cooker hoods or the direct exhaust. And studies show that definitely direct exhaust cooker hoods are the better solution for the indoor air quality. But the challenge so far was that how can we keep the pressure balanced? If I have the 100 CFM coming to the outside air and I'm turning up my cooker hoods with the 50 or 80 CFM, how does this system can be balanced itself? And that's why it's typically you see that they are going with the recirculating hoods, which kind of compromising the indoor air quality or comfortable indoor space for the people, where was the kind of the main goal of the passive house buildings. So this kind of the solution that we are talking about is taking care of those kind of the requirement for passive house. So CASA is kind of the more smaller range of the product, is with the 50 CFM to 500 CFM. They are kind of the same as the commercial unit. They have a rotary wheel because of the higher efficiency on the sensible and latent part they can provide to the building and meet the requirement or energy target of the project. So this is the internal component of the unit. Filters, this main section is the rotary wheel, and these are the fans. One of the things that this solution can be differentiated for specifically for passive house project is the kind of the ability to balance the airflow when you have a direct exhaust kitchen. So we have the kind of we are taking two different solutions. So you can, for this unit, you can go up to -10 degrees Celsius without any preheater, because these are a smaller units, so it's different from commercial ones. But also you can integrate the kitchen hoods, kitchen exhaust to the smaller units, and the bypass. This is the unit is built in a way that bypass the exhaust of the kitchen, of the core heat exchanger, so your exhaust of the cooker doesn't pass through the energy recovery rotor. Or you can have a separate exhaust and the unit itself balance the airflow inside the space. So that's kind of the solution that Passive House Society was looking for a long time, to kind of having increased the indoor air quality with the direct exhaust kitchen hoods or cooker hoods, but at the same time they kind of not put the building under the unbalanced airflow for a long time. So that's kind of this new solution can be automatically adjust the pressure. Also, it has excuse me, it has more features like to control the humidity. One of the challenges Passive House Society can comment on that is when you have an airtight building and even you don't have a proper ventilation solution or boost airflow to remove the humidity, you may gonna get the humidity built up in your space. And with specifically for passive, it needed to have either a kind of increased airflow solution to able to remove the humidity from the space when it's the humidity spike. So this requirement is built in as a standard in this product to able to keep the humidity, balance pressure, and CO2 level in the space without any extra control pieces requirement. So everything is kind of built in as for the residential use for high performance building. And this one can be a sensible or latent recovery. So it has both options. So you can have ERV and HRV option for this one. That's kind of what we have for the CASA. So I think we can answer any question that people have.
Somebody's asking for access to the slide deck once the presentation's over.
Sure.
Okay, so yes, and what you can do is contact Passive House Alberta, the education email, and we will provide that for you. If that's all right. We'll email it, the presentation to you. Any other questions? I have a question about preheat. So if you don't need a preheat to minus 10 degrees Celsius, is there a preheat for when it's colder than that?
It depends how you are designing the system. Yes, if you don't want to lose the efficiency of your ventilation units, you you can add a preheater to the ventilation, to the mechanical ventilation. But what is kind of the over lesson learned through the different passive house projects is better to add whatever post heating that you have. It kind of design it for worst case scenario. In that scenario, whenever the unit is losing the efficiency or there's colder outside, that's the supplier temperature drops, the units, you can modulate the capacity of your post heating component to keep the required supplier temperature. So that's what we have seen, and it's be a more acceptable approach to have it the post heater rather than preheater.
Okay. I think Richard is as part of the Swegon group and has set a comment in the chat. So that says the Swegon Gold or Casa units will slow down the wheel rotor all the way down to 0.5 RPM. So it just slows down. It's not not cycling and cycling the way that most HRVs are. Okay.
Yeah, that's kind of the defrost, preventive defrost method that we have, is slowing down the wheel to control the frost on the exhaust.
Okay, so that does it for 4 minutes rather than the normal 20 minutes. Yeah, okay.
Correct. It does the 4 minutes slow down, and then it's checked what we do is be monitoring the pressure drop of the heat exchanger. So if it's try to slow down the rotor for 4 minutes, and if it's still the pressure drop is higher than standard pressure drop, so it's try another 4 minutes. So it's the slowing down and speeding up the rotor to get the balance point where it needs to be. So that's the process the unit goes through. And if it does for I have to check the numbers, but if it does it for 2 hours or an hour, that's showing an alarm that something is wrong, because somebody needs to double check to make sure it's nothing clogged the wheel or iced up the wheel. So.
Okay, so a couple other quick questions. So the HRV unit will still need to be plumbed to a drain? So removing.
Yes,
Yep,
yes,
okay.
HRV needs to be plumbed to the drain.
And the ductwork for these units, proprietary, or is it just normal?
Any ductwork can be,
okay.
yes. We don't require the specific ductwork. The only thing that I explained earlier in the other slides that we have is the consultant typically is encouraged to define a specific leakage for the ductwork to to make sure it's to pass the blower test or the commissioning of the building that can be certified if the building is going through the certification process.
When the unit's being used as makeup air, it automatically senses depressurizations. That's just an automatic. You don't have to set it, or is there an interlock with an exhaust?
You can interlock. It's automatically being done, so it can be interlocked to your cooker hose, or it can be interlocked to the external exhaust. So the unit can be the switch to keep the balance. So yeah, if you get to the point that the unit may change to be a makeup air unit rather than recovery, if you get so much unbalanced airflow, so you don't get on that much recovery on your ventilation use. So if you have a great unbalanced airflow through your energy recovery unit.
Okay, and then cost. One question that should come up from anybody is just a price point without telling us exact cost, if we're comparing it to other units that are used for passive house projects.
Typically that's what I was earlier discussing on the other slide deck about the lowest cost in the market versus the certified high efficiency. So typically you kind of are looking at about the 10% to 15% premium, kind of the sometimes, but it depends on the kind of the overall system layout as well. But it's like the, because if you're looking at the unit itself, maybe it's kind of to be 10% more expensive. But if you're looking at the saving that's kind of high efficiency unit can done on the post heating or post cooling, that's kind of the saving you can get on your boiler sizing, on your chiller, or if you have VRF system and you're downsizing your condensing unit, those are the savings can be done, can we get from other companies. So it's overall cost of the project is not that expensive, or mechanical equipment cost of the project is not that more expensive than the regular.
So does Swegon offer assistance in mechanical sizing and consulting for the projects, specific projects?
That's Rodney is kind of their Swegon representative. So
okay.
Rodney is our local support in Edmonton.
For the Alberta office. And of course, anyone in our BC office would also be able to assist with any of your project sizing and design needs in concert with Swegon. And I believe to Ashkan, Swegon, they also offer assistance in payback analysis, is that correct?
Yeah, we can do some payback analysis as well, and the energy modeling, and do that based on the energy costs that we have currently. We can do the return of investment calculation as well.
So just to be sure that I understand what that means is that Swegon will help with understanding the demand, the heat demand and the cooling demand for the building. Is that right overall, or?
This is typically comes not from Swegon. This is the heating load demand and cooling demand coming from the energy modeler in the project, and also the mechanical consultants. Yes. We thought you are asking about the sizing the equipment in an optimized way to kind of meet the loads. That's what.
Okay, so that's the sizing of the equipment as well. Okay,
yes.
That's great. Good.
Yes. And one of the benefits of the Swegon's Gold and the CASA units is because of its high efficiency and its basically improved latent recovery operations, it's really good at dehumidifying a space, which also can assist in reducing your cooling demand loads as well from the ventilation perspective. So it actually provides you some assistance in your overall modeling for what your cooling demands will be for the space as well.
Okay. Yeah, everything's interconnected.
That's right.
Exactly. The strategy is always using the recovery unit as a first stage of heating and cooling or dehumidification, and the rest of the loads we handled by the external, like the post heating or cooling kind of the coils that you have in your system. So it comes as an integrated solution, but it's it's always use the energy recovery unit as a first stage of heating and cooling. And that's what Rodney was meant, that if you have hot and humid outside air in the summertime, or that's kind of the energy recovery can remove the humidity of the outside air and reduce your dehumidification load on the post-cooling and reheat size.
Okay, does anyone else have questions? Okay, is there anything else to add about the Swegon unit? Anything else that you'd like to add before we say goodbye?
I would add about overall on the passive house or high performance building, rather than just the Swegon, is kind of what we have learned on these high efficiency buildings or passive house is getting the information from all parties and working together is kind of to be a more successful strategy, just rather than working individually. As an example, energy modeler typically doing some energy modeling with certain parameters like the specific fan powers and the efficiency that they need for the ventilation units. And sometimes this information is not get translated or transferred to the mechanical engineer. So that's kind of the communication really matters in these projects, because all parties are interconnected to the work, and any of these kind of not get to the other team, it's kind of they may get to the wrong spot and not getting to the right goal that the project is aiming for. So that's what we have learned, and as a manufacturer, always encouraged kind of getting all the information rather than the going to the selection. The other thing is about the controlling the equipment on these projects. It matters a lot because how you, as I was talking about, how you run your equipment is more important just to sizing your equipment, because you can be wasting energy but not running your equipment correctly. So that's the other part. We always kind of get involved in the writing the sequences, how you run your equipment, to kind of make sure it's kind of get everybody on the same page on the controls part of the this equipment.
Okay, so that's more of a call for integrated project delivery, whether that's in the contract or not. That's really has to be the approach for a successful passive house or a successful project at all. So I think
the passive, correct. The passive house is the place that, because it's going through the certification, if that step is not happening, it's gonna show up in the certification stage. That's why it's more showing up in the passive house compared to the other.
Right. So everybody should be at the table at the very beginning, including the ventilation guys.
Yep. Correct.
Correct. And then also touch base throughout the remainder of the design and through the construction phase as well, to ensure that everything's covered off and if they need any assistance from the other team members as well.
Yep. Awesome. Okay, I think we're going to call that a day. Thank you very much for coming today and presenting these units. And it's pretty exciting. Especially the residential ones are pretty interesting, and that it's great to see this approach. I think next month I get to present. I'm going to be presenting something to do with boots on the ground and working with contractors and consultants and getting a successful project out of the ground. So with that, thank you very much for attending, everybody, and we'll see you in a month. Thank you.
Thank you.